DeepMind continues its streak of high-profile AI accomplishments by inferring holes left in ancient Greek texts. The technology, called Ithaca, promises new advancements in the field of epigraphy, the process of filling in voids within incomplete documents. Previously, this was a field which required rich human insights into a particular language and time period. Scholars would generate hypotheses for the gaps within texts based on an incredibly rich background understanding. Thanks to 178,551 existing transcribed texts and the lexicon of Greek personal names, where individual locations and dates were assigned to each example of a name used in ancient Greece, Ithaca has achieved a superhuman level of accuracy at reconstructing ancient texts. It is thrilling to see the latest technology cracking some of humanity's oldest secrets. It's very poetic in a way. The US has eliminated the requirement for user controls within vehicles. It's difficult to imagine this will lead to the toaster-like concept cars companies have been teasing anytime soon. Government tearing down the guardrails before there is substantial friction with industry is a remarkably proactive move, especially relative to the endless deliberation we see in the US about maybe perhaps one day regulating social media companies, maybe a little bit at some point. Right now, this will probably only affect projects like Waymo, which operate in a limited capacity as a taxi service within Arizona. DARPA has begun to address the alignment problem. The issue of aligning AI with human intentions is a very popular topic among AI circles, possibly because it is so easy to explain, but so difficult to solve. Simply put, the alignment problem is the inability of humans to express our intentions in a way where AI will execute it without any unintended consequences. When humans communicate, we do so in an extremely context-rich way, with tons of assumptions and inherent knowledge already in place. Taken to its extreme, some theoreticians have imagined dystopian futures, where the alignment problem has led to global extinction. But even in the present, the issue of designing rewards for training agents can be difficult, and in some cases, totally intractable. From the perspective of national security, the need is certainly there. The Department of Defense needs rigorous, quantifiable, and scalable approaches to evaluating and building algorithmic systems for difficult decision-making, where objective ground truth is unavailable. Difficult decisions are those where trusted decision-makers disagree, no right answer exists, and uncertainty, time pressure, and conflicting values create significant decision-making challenges. DARPA intends to address these problems by comparing human judgment with machine judgment and over time closing this gap. Both the problem and the approach are nothing new, but we can always hope that DARPA will succeed where many others have failed. It wouldn't be the first time. One of deep learning's founding fathers, Yoshua Bengio, has introduced generative flow networks. These networks promise to deliver a new kind of process, operating at the intersection of reinforcement learning, deep generative models, and energy-based probabilistic modeling. I am still learning how these networks really function, but their potential seems quite good. In particular, Bengio notes their ability to implement System 2 style inductive biases. System 2 being an idea taken from Daniel Kahneman's Thinking Fast and Slow, referring to the more deliberate kind of activity such as navigating in an unfamiliar city or summing numbers in your head. Bengio also notes the potential of generative flow networks to sequentially construct molecular and causal graphs. If you're interested in understanding how this new kind of network operates, Professor Bengio has provided an excellent tutorial with a well-written complete description. There's also a new episode of ML Street Talk discussing them on a more philosophical level. The gene expression of DNA is an old and very difficult problem within biology. Figuring out what DNA regulates particular traits within a living organism seems like a straightforward problem, but gene expression is an incredibly complex issue. Taking the gene expression of a particular yeast, whose name I will not be butchering today, the researchers were able to compare the production of yellow fluorescent protein within a regulatory DNA sequence called a promoter. By running this experiment on 30 million different promoters, each containing 80 base pairs, the scientists were able to use a convolutional neural network to predict gene expression from the data. The resulting network demonstrated an impressive level of generality, given the relatively sparse sampling of all possible base strings. This is encouraging as we consider sampling for more complex gene expressions, for example, creating models for human gene expression. There's a new player in the processor space, the WOW processor, or wafer-on-wafer processor. The chip, called BO IPU, or Infrastructure Processing Unit, is the result of a partnership between Graphcore and TSMC. It is specifically designed for AI workloads and is capable of running more than 8,800 threads. In total, the BO IPU offers 89 petaflops of AI compute. Graphcore intends to use this new compute power to build a singular computer for AI that can rival the human brain. This system will be called the Good Computer, after Jack Good, a computer science pioneer who was one of the first to conjecture about superintelligence in his 1965 paper, Speculations Concerning the First Ultra-Intelligent Machine, where he stated, "Let an ultra-intelligent machine be defined as a machine that can far surpass all the intellectual activities of any man, however clever."